Binary search is a simple algorithm for finding objects in a sorted list. The basic idea is we keep track of a current window. Then we figure out whether the object has to be in the left or the right half of the current window, depending on whether it is less than or greater than the value that's in the middle of the window. So in this example, we're going to look for the salmon steak, which has value 4. Our initial window is the entire list of 7 objects. Then we look at the object in the middle, in this case seared slaughterfish with value 5. Since 4 is less than 5, we know it has to be the left of the seared slaughterfish. We look in the middle of that. Mammoth cheese ball, value 3. It has to be greater than that or to the right. And we're left with the salmon steak, value 4. So we found the object we're looking for. Let's consider Mergesort, a simple yet effective sorting algorithm. The essential idea with Mergesort is to take our entire list, we recursively split it into 2 halves, we call them sublists. Then we sort each sublist, and then we merge them back together. In order to merge, I'll show you in a second, but what we want to do to merge is we take each sublist, and then we take the least element of each sublist at the beginning, and we compare which one is less. The one that's less we put at the beginning of our new list. And then we essentially, one of our sublists is smaller and we continue. So here you can see we've just sorted all the sublists of size 2. Now we'll go up. We'll sort the lists of length 4. So we have to merge together our first 2 sublists of length 2 to make our first sublist of length 4. And you can see this is happening here. Now we're going to have to sort the second sublist of length 4 right after we finish this one. In order to sort the second sublist of length 4, we need to merge the second last 2 sublists of length 2. And they're already in sorted order, so it's okay, we don't have to do any work. Now we're going to want to merge the entire thing. We have 2 sublists of length 4. And remember, the way we do this, the first element stays in its place, because the first element is the least element of the first element of the first sublist and the first element of the second sublist, so it stays in place. And we essentially just continue. We take the least element of the first remaining element from each sublist, and then continue until we end up at a point where one of the sublists is entirely depleted. Then we just append the rest of the second sublist to the end. So you can see this process happening here. We're essentially merging the 2 sublists of length 4 together. And Mergesort works in n times log n time, because merging at each level takes n time, linear time, and then there are a total number of levels of log 2 of n, log of n. So logarithmic times linear time is n log n, linear arithmetic time. And this is why this is a great sorting algorithm. Now let's look at Quicksort, another n log n sort that's slightly faster in many cases than Mergesort. The essential idea in Quicksort is we're going to pick the middle element of the array as our pivot. Then we want to swap elements such that everything on the left of the pivot is less than the pivot and everything on the right of the pivot is greater than the pivot. Then we repeat. So the basic idea with Quicksort is that we keep pointers at the beginning and end of the sublist we want to sort. And then we're going to continually bring the pointers on the left to the right and the pointers on the right to the left under certain conditions. Namely that we keep incrementing the left pointer until we reach a value that is greater than the pivot, and we keep decrementing the right pointer until we reach a value that is less than the pivot. And then we swap the 2 values at the pointers and continue. This makes it so that everything on the left of the pivot is less than the pivot and everything on the right of the pivot is greater than the pivot. And we continue until the 2 pointers cross. So as you can see, in this case, essentially, now we're just trying to sort the rightmost 3. And we do that by, again, exchanging the pivots. And now, since we've sorted the rightmost 3, then we have actually finished. And we're going to proceed to celebrate by firing at the wheel of cheese with our crossbow. Next, we place the wheel of cheese at the end of our list, and it is sorted.